late. Oh my gosh. I can't believe I'm late. Not even 2 minutes late, but I hope nobody noticed. This is embarrassing. Oh, this is so unprofessional. What should I do? Should I explain to everybody what I was doing? Why I was 90 seconds late? No. I could tell them I was golfing with my mom on Mother's Day, which is a very kind gesture. They don't care about that. They don't care about my mom. They'd probably say, your mom's gonna love your naturally curly hair. She probably bought you that shirt. Oh my gosh. She did buy me this shirt. Oh boy. What should I do? What am I gonna do? Should I start the episode? Should I just hope that nobody noticed that I'm late? Maybe I'll say, hey everybody. No, it's too late. Just focus. Pretend like you know what's going on. Pretend like you've been here the whole time. Maybe nod. Act like you're thinking of a good question. Where are we in this episode? Have we even started the life cycle of the star review? Are we talking about galaxies? Oh, this is awful. If anyone asks, I'll just say I was in the bathroom and hope they don't ask for details. That's a great plan. No one noticed. You got this. All right, now that we're all finally here, let's quickly review this chart that shows the life cycle of a star. This was for homework last Thursday. We'll begin at the beginning. This cloud of dust and gas in space is the stellar nursery or the stellar nebula, the birthplace of stars. Taking the low road appropriately, that is going to be a low mass star. This arrow, we'll notice, is longer than the arrow above it, and that indicates that low mass stars spend a longer time in the main sequence. That's when they're fusing hydrogen in their cores, and after they fuse through all of their hydrogen, then they begin fusing helium, which causes them to swell in size and become a red giant. Following the red giant phase, once all the fusion has occurred of the helium, then the outer parts of the red giant float away, leaving behind a smaller remnant, which is extremely hot but not very bright, and that is a white dwarf. Taking the high road now, the high mass stars tend to be bluer. Remember, low mass stars are kind of yellow, orange, red, and high mass stars are bluish. They have a shorter main sequence, so even though they have more hydrogen, they fuse their hydrogen at such a great rate that they spend less time in the main sequence. When they start fusing helium, they have a similar reaction where they become enormous. These pictures are in no way to scale. Supergiants can be up to 1,000 times larger than our current sun. And then the supergiants have that exciting finale, an explosion of sorts called a supernova. And there are two options following the supernova, depending on how large the star was to begin with. One option is a point in space where gravity is so strong that not even light can escape. That's a black hole. The other option is a sphere of very dense neutrons called the neutron star. And hopefully that made sense on the homework. Please check for accuracy. Speaking of self-luminous sphere of plasma held together by its own gravity, that would obviously be a star. And a large group of stars, gas and dust, held together by gravity. We previewed this last week on Thursday in Zoom. That is the definition for galaxy. And today we're going to talk about the three major types of galaxies. There are examples pictured here. We have spiral galaxies, elliptical galaxies, and irregular galaxies. Spoiler, they're classified largely based on shape. Let's take a look at these three pictures of spiral galaxies. Obviously, the one in the middle is not an actual picture. The other two are. But spiral galaxies have a common structure. They have a central bulge or band composed of condensed stars, lots of stars, but not a lot of gas and dust. And then around that, they have a disk of or spiral arms that have a lot of gas and dust, and there's new star formation going on in those arms. So again, the spiral arms is where stars are actively being formed. An example here is a barred spiral. We can kind of see the bar going across the middle of the galaxy. This is a more classic pinwheel galaxy. And those are different than elliptical galaxies. Elliptical galaxies are sometimes appear to be like a single point of light, but they're actually hundreds of millions of stars that are close together and without a lot of gas or dust, meaning there's no new stars being formed. They're typically composed of older stars. As you can see in these three pictures, they're distinctly different and sometimes an ellipse, hence the term elliptical. Here's a picture that shows a pretty bright elliptical galaxy. There's some other galaxies pictured there. And then lastly, let's talk about irregular galaxies, which are appropriately named because their shape is often chaotic in appearance. And it's a galaxy that is neither spiral nor elliptical, would be classified as irregular. Oftentimes, irregular galaxies are the product of two galaxies that have come close to one another, quote unquote, colliding, but really it's just gravitational distortion changing the shape of both galaxies. As pictured here, no clear spiral or elliptical shape to that collection of stars. So to recap, we do have three types of galaxies: the spiral galaxies, where there's a lot of gas and dust in the arms, where there's new star formation; the elliptical galaxies, which are composed of a lot of older stars, not much gas and dust; and then irregular galaxies that don't have any specific shape. What we're going to do with this, we're going to test your knowledge of what we just went over on Canvas. There is this document. You can print it or snag it and throw it into Notability. And then you're just going to fill in the blank. And if the words or picture refers to spiral, you can write spiral. And if it refers to elliptical, write elliptical. If it refers to irregular, you can write irregular. If it refers to all three, feel free to write all three, or at least the first letter of all three. This assignment is due Tuesday at 4 p.m. You know, I don't know if anyone noticed that I was late to this episode. Time to celebrate with a Diet Dr. Pepper. I hope this is quiet. I was in the bathroom.